Okay guys, so this is an introduction to 8.2. Okay, this is a little pre-8.2. And we're going to talk about a critical value, Z crit. We call that Z crit. Okay, critical value Z. So let's say you sample 60 students and find 47 like the orange circus peanuts. Make a 95, 98, and 99% confidence interval. So you know what you're talking about. I'm talking about those, they look like foam. They're those little orange, they're candy, they're disgusting. I like candy, man, but those orange circus peanuts? No. No. Okay? So when you're doing a confidence interval, okay, you're doing a confidence interval, this is what it looks like. This is the mechanics of it. You have the statistic plus or minus a critical number times the standard deviation. This makes up our margin of error. Okay, the after the plus or minus is the margin of error. This is the standard error. Standard error, margin of error. Okay, we'll talk more about that. So when we're doing proportions, it's going to be p hat plus or minus a critical z, z goes with proportions, times p times 1 minus p over n. So this is how we do a confidence interval. To me, confidence intervals make the most sense because why are you doing a confidence interval? You're trying to find out what the truth is. You're trying to find out the truth, okay? We don't know. When they tell you what P is, they tell you what the percent of people in the population who likes circus peanuts, they don't know that. You use statistics to try to find that, okay? So we don't know P. So because we don't know P, all we can base our findings off of is we need to use our P hat. We use our sample. Okay, are we always going to be right? No. But we expect to be right about 95% of the time, or 98% of the time, or 99% of the time. Okay, that's what we hope. That's what we hope. Okay, so we do our p hat. Well, that's going to be 47 divided by 60. So if we did 47 divided by 60, that's going to be 0.783. So when I set up this, the mechanics of my problem, I've got 0.783 plus or minus. I'm going to leave this as a critical Z for now. I have to show you how to do that. That's what the whole point of this is. Okay, critical value Z, that's what we're talking about. But we can do this. This would be the square root of 0.783 times 0.217 all over our number 60. Okay, so do I simplify that? I do. 0.783 plus or minus this critical Z times 0.0532. And now it comes time to find out what that critical Z is. Okay? So we have to figure out what that critical Z is. Okay? Ready? Critical Z, Z crit, is a z-score. It's a z-score. Okay, it's a z-score. Now, we're going to concentrate right now on doing a 95% confidence interval. A 95% confidence interval. So you might think that we're going to use 0.95 or we're going to use 0.05 in our calculations. But what I want to do is I want to grab the middle 95%. I'm not taking my normal curve and saying I'm taking the top 95%. The 95% is in the middle and it slides up or down based on what our p-hat is, okay? Our confidence interval, our little 95% confidence interval is going to move up and down based on what our p-hat is. But we're capturing that middle 95%. So, when I go to find a z-score for that, if I just wanted the top 5%, we would do inverse norm 0.95, but I don't want that. I want the middle 95%. That's going to move, okay? That is going to move on us. So because I'm choosing the middle 95%, I'm cutting off 5% at each tail. There's 2.5% over here. There's 2.5% over here. So when I do my inverse INV NORM, okay, it's going to be 0.975 because I've got 2.5 at each tail, okay? Or inverse norm 0.025. Either one of those will work. And when you do that, we're going to get 1.96 or negative 1.96. It's plus or minus. It doesn't matter which one you do, okay? But if you look, that's like 2 standard deviations. 2 standard deviations, okay? 1.96, really close to 2 standard deviations. So when we do this, we would do 0.783 plus or minus 1.96 times 0.0532, okay? So, if I wanted to find, so for a 95% confidence interval, my critical Z was, we used inverse norm 0.975 or 0.025. Either of those work. So what if I wanted a 90% confidence interval? Okay, we have 10% split in the 2 tails. So if I have 10% split in the 2 tails, on each tail, I'm either going to do inverse norm 0.95 or inverse norm 0.05. So what if I wanted a 98% confidence interval? Well, there's 2%. There's 2% in both tails. So we would do inverse norm 0.99 or 0.01. Okay? So you take the amount that's left from 100 and divide it by 2 to find your critical value Z. Okay, let me see if I have an answer for the circus peanuts. I do. Uh-oh, what did I do that for? I don't know if I did it for a 95 or a 96. So I don't have one. I can do it quick. Ready? Here we go. So we do 1.96 times 0.0532. And I get 0.783 plus or minus 0.1043. So if I do 0.1043 plus 0.783, I get 0.8873. And if I do 0.783 minus 0.1043, I get 0.6787. So, I am 95% confident that the true proportion of people who like those orange circus peanuts is captured in the interval from 0.6787 to 0.8873. And that is your first confidence interval.